My name is Adair Rodriguez from Ion Associates, and today I will be co-presenting with my colleagues Marvin Govindan and Raul Dominguez. This is a summary of today's agenda. At the beginning, we'll have a recap about IoT processing and artificial intelligence. We'll cover also the solutions provided by our partner Synaptics for video, audio process, and wireless connectivity. And finally, we'll cover some complementary solutions like memories, sensor, power management solutions, and some recommended connectors for these specific applications. So let's begin with the recap. What is IoT, or what are the terms that have been used in this market in today's technology? Many of us have heard about IoT or Industry 4.0. These two terms are the evolution of the technology or are related to the evolution of the technology. So we consider it's important to take up a couple of minutes to talk about these two terms and their relationship about them. So what is IoT? When we talk about IoT, we will talk about a concept that refers to the internet or interconnection between some objects and the internet. Let's talk about some live example or some example that we see every day. Let's consider our smartphones or smart watches, the tablets, for example. They all all the time are capturing data and sending the information to the internet. Once they are in the internet or in the cloud, for example, the data received is being processed, and then after that will be received maybe by the user. One example about this will be, for example, when we talk about a color, a dog's color that has a sensor, an embedded sensor. The color or the device that is being carried by our dog, for example, is capturing data all the time. This data is being sent into the cloud, and not immediately, but after maybe a couple of minutes, an hours, or some days, the data can be received by our smartphone, and we can get the information that was processed by this information. So the thing about IoT is that all the devices collecting data and sending the information to the cloud to be processed and after being received or by the end user. Another thing to consider is that we are seeing in the market is also automation. So what are the relationship between automation and Internet of Things? These are two terms that are often meet together because they are both technologies designed to facilitate users' life. Automating specific processes, allowing maybe remote control, maybe also simplifying plant management. And the idea for this is to generally optimize the management of the entire environment in which they are placed. Sorry. So when we talk about automation, we see automation as a closed system with the interconnected systems structured in hierarchical way and well organized. This vertical approach allows us to centralize the management of the entire environment, both internal and external. Automation refers to a single control and coordination between different functions and scenarios, all of them pre-programmed in sequences of actions that can be activated within a single command. On the right hand side, we can appreciate a hierarchical structure where the further up the pyramid go, the more control evolves to a single command structure. What is the relationship, or what are the difference? Automation systems are, as we said before, are closed systems or contained systems. They do not necessarily need to interact with the outside world. So this data processed in all these systems is stored and protected as, and since there is no interface with the outside world, all data is well protected. When we talk about IoT, these devices, as we said before, IoT refers to capturing the data and send it to the cloud or to the internet to be processed on the outside maybe. So when we talk about IoT, these devices will be exposed to the external environment, and in this turn might be a little bit more vulnerable. Another concept that we should consider is Industry 4.0. We've seen the different evolutions of the industry, starting with Industry 1.0, 2, the 3 that relates to the automation of the processes, and Industry 4.0, in which we include the sensor, in which we include more processing, internal or external. Okay, so this makes the process or maybe a company or a plant more efficient. We can be able to predict maybe some processes, some failures that could happen in the environment and react at the same time as fast as possible. Also, with all this integration, we could be able to get all the information, maybe not only the information that is related to the specific process, but be able to receive a lot of data that maybe in the cloud or with the support of big data, we could process and predict more processes or future actions for the entire plant. So this is the reason for that we are talking about, and the Industry 4.0 is really important in today's uses. This is one example, a smart factory that with the implementation of these sensors and processing external and internal help us to coordinate better all the processes, giving a good timing in the end results, a good processing and a good progress. So we can get in real time red flags, alarms, or if something is really wrong during this process in the plant, it can be detected or maybe avoided. So what about IoT and internet, IoT or Industry 4.0? This relationship focus on the implementation on, well, we already see that the receiving the data, receiving the information, for example, for the camera that are connected within the plant, all this information being processed to the external world, and maybe after that, an end user being able to receive the information on a smartphone or on an external device and another side of the world. So this is where IoT and industry could merge together. And as I said before, with the wireless solutions, let's say SIM cards, for example, with cellular plans, or the services provided by, for example, or related to these SIM cards, services that allow us to connect all the devices using cellular connection. But not only cellular connection, we can use Wi-Fi, we can use Bluetooth, for example, or we can use wired connection like LAN networks. we can use we can get all this information, all the data, and send it to the external world. And after that, being able to use also the processing of the devices, whether it's internal or external, as I said before, to get use of this all this data. Okay. So, what about the data process? What about the edge processing? What about cloud processing? Let's talk about this with Marvin, with my colleague Marvin.
Hi everyone. Yes, so thanks, Ade. So in this section, we'll just talk a bit about the data processing, which can encompass a lot of different things. So if we move on. Okay, so when we talk about processing, we get data. So we have a sensor. The sensor could be a camera, a microphone, any kind of dumb sensor. It could be very simple, it could be analog, or it could be digital. Nowadays, we have a lot of digital interfaces to our simple sensors. So what happens, what is pre-processing, and what is edge processing, what is advanced processing? So pre-processing, you get an audio signal. You get an audio signal, it's got a lot of noise in there, high frequency noise. Our voice is in the 300 to 3.2 kilohertz bandwidth. So we need to get rid of that noise. So we do some filtering. We put some kind of bandpass filter there, or a high pass filter, get rid of the high frequency noise. And then we take that signal and we quantize it, and we make it a digital representation of that same signal. So just with a simple 1D signal, we're digitizing, we've done some level of processing on there. And on that, we had on headers and preambles and other things on that to make it a good digital signal. And then when you talk about edge processing, well, we do things on the edge, right? So why do we do them on the edge? Well, we've got our signal now, we've got our digital signal there, and do I want to send all of that audio signal to the cloud and store it there, all that information? Or do I want to compress it? Do I want to extract some things from there? So that's where we sort of start to play with that data. It could be a 2D signal, it could be an image, or it could be audio. So do we really want to send all of that information, or do we want to analyze it in some way? And then when we talk about advanced processing, then what other things are we thinking about? Well, these days we have devices where it recognizes phrases. You know, you can talk to your devices to turn them on, to order things, maybe to find out if we have alerts there, it's detecting hazards, earthquakes, many things, alerts to help us in our everyday lives. And there could be even other things, face detection to detect users, and even other things like going from one format to another format. If you see one signal in one format, it needs to be converted for a different display or something, so transcoding. So there's many things we can do with data when you process it. So yeah, just talking a bit more about that. So audio, yeah, we filter it between those typically 300 hertz, 3.2 kilohertz, get rid of noise. We sample it, we quantize it. We may do other things with that. If we're going to do some local transmission, we might do some compression expanding, which is typical for audio, and we do some encoding on that. What sort of hardware do we use? Well, these days we're looking at microphones, multiple microphones. We don't usually just use one microphone now. We have amplifiers and maybe digital to analog converters on that first level. For images, we captured on a camera. These days we captured and automatically converted to digital. We'll have some sort of digital format there. But even on that level, newer devices are now like filtering the noise, doing color correction, contrast correction, lots of things that you used to do on the desktop after you've recorded your images. It now comes out of the device already pre-processed to some degree. And also we do other things too, like we upscale it and downscaling it for different displays, different devices. So these days we'll come across a lot of HD cameras which already have a good digital output, and there's already some pre-processing done on these devices. If it was a simpler device, a simpler camera, we might use some physical filters on there, some lenses, some polarizers to help us correct any images in the physical domain, not the digital domain. And we'll find other components in there like amplifiers and video DACs as well. So we mentioned that on the edge, we've captured maybe our data with a microphone or a camera. So that's maybe a lot of information there. So now what do we want to do? Do we want to send all of that to the cloud? Probably not. We don't want to send gigabytes per day or terabytes per day to the cloud. It will have high storage costs. If you have multiple cameras, it will be saturated very quickly. And it will cause multiple carrier costs. And we've seen that at the beginning of this industry, we've seen that happen. So we need to sort of do some sort of processing on that to get the useful data from that before we send it. So if we're looking for, say, license plate for a vehicle, so we detect all the numbers of all the vehicles going past, but we really want to know that who hasn't paid. And maybe that's what we're looking for. So what can we don't want to send maybe all those images to the cloud. We just want to send actually the numbers. So we detect those numbers, and maybe we send all of that, and then we dump the data that's not useful for us. So we check on a physical database, right? For face detection, we don't want to send images of every single person's face that goes past. So we sort of generate like a map, look at distances between certain features of the face. And we generate like a coordinates map in a different domain, a 2D frequency domain. And from that, we classify that face with a set of coordinates. That information is sent, which is a highly contracted information. We're talking about maybe a byte or a couple of bytes of information or a few bytes of information, but not megabytes of information. So that helps us to reduce that packet load that we're sending across the network. So we reduce the packet load using data extraction or processing. We lower the carrier costs, and we lower the cloud storage costs as well. So that's why we want to do processing maybe on the edge, maybe at the level of the device, which could be the camera or the microphone, or maybe at a more local node. So maybe if you have multiple cameras, it all feeds back to one node, and the processing is done at the node before it gets shifted to the cloud. So maybe that all those nodes will be connected by some mesh network where you're not generating high costs. So in advanced processing, what do we see these days? So just think about audio. The easy one is noise cancellation. It's almost like a standard now. So we probably have 2 channels there. We'd filter out the audio, in particular 2 replicas of the audio signal. We'll filter out the audio in one. We'll have a noise signal there, and we'll subtract that from the original signal. So we'll cancel that noise. It can be done physically with multiple microphones, or it could be done digitally with maybe just one audio stream. But also, what do we want to do? We have multiple mics now. It's uncommon to just consider one microphone for new devices. We want to know which direction that voice is coming from. If it's coming from the speaker, or if it's coming from somewhere else, maybe some sort of distance approximation. So we need to know where the direction of that voice is coming from these days. And also that helps us to detect, if we now recognize that person's voice, we can know where they are relatively. And usually we might have to train like activation keywords to turn things on, turn things off. This could just one phrase for a device that needs to activate, either opening the door, opening blinds. Typically in a small neural network, that would take maybe 70,000 samples just for one phrase. So just to be able to have something that works more or less. And once you have the algorithm, and then you can just have that stored locally on a device, which is maybe your edge device there. And then the user would initially train it with their voice. maybe by saying the same phrase, and that sort of is mapped to the training pattern inside the device. Okay. For images, well, when we process these images, what do we want to do? If we're doing face detection or object detection, we normally tend to have these images are in 2D, obviously. So we do some edge or boundary detection. We'll do some segmentation of images, some thresholding, some classification of objects, and there's many other processes. These are all existing libraries now. So you can train your what you're trying to detect with maybe 100,000 images or so, and you follow the steps to generate an algorithm there. So that can even, once you have that, you put that onto your edge device to be able to extract that object detection before sending that information off to anything. If you detected an object, or if you're responding to an object, if a child has walked out in front of a vehicle, for example, into the road, you might want to set up an alarm. So you want to maybe do that real time at the edge. You don't necessarily want to consult that in the cloud. And moving on to, let's talk about the cloud a bit, cloud computing, big data, and other things. So let's check this. So yeah, initially, now we take pictures, when we record things, more frequently it's getting stored in the cloud, okay? From your phone, your tablet, or your laptop, we can have it configured automatically to send things to the cloud, especially when we're on a free connection, not a paid connection. And that helps to control those costs. So yeah, SIM technology, carrier technology, 4G, LTE, basically from the minute we leave our laptops at home and go on the bus with our cell phones, and then arriving at our workplace with our laptops again, we're always connected. Okay, sometimes over secure lines and sometimes on non-secure lines. Okay, so we can configure our devices to automatically upload things. We can access our information from everywhere. That's the big advantage. We don't even have to carry a laptop with us. We could literally just have the device configured. We'd have one at home, one at work, and in the middle time we have a tablet or something. So we can access the same information from anywhere. So we have all this useful information on the cloud, or maybe we're collecting useful information and storing it on the cloud. Now we have to be able to see it and make use of that. So we have all this information, and we need to maybe put an application where we can see it. So we create dashboards. Okay, so dashboards, we have some rules there. We set up these rules so we can start to process the data and process it in the way that we want to see the data, and it's represented in a way that's useful to us. So we've had all this edge processing where we've now got the useful data, and now we're going to look at the useful data with an application that we develop. So usually the cloud platforms have applications that we can develop or modify, or we can develop using a third-party tool, and we can see our data graphically or in ways that's useful, and we can have other client access and do other things with that. Okay, so the dashboards give us access to our stored information, our useful information. So then we come across, now we're storing all this data, and we come across, maybe we have lots of data. So we see data, and people talk about big data, right? So big data is just large amounts of data, right? So we talk about structured data and unstructured data. So we could be data which is just feeding into a database, and it has some sort of structure to it. It's something we're looking for, so we can extract it easily into our dashboard. It could be unstructured, coming from multiple sensors. Maybe it needs to have a bit more processing done so that it's not as chaotic. But eventually we need to do something with this data, right? So when we talk about big data, it's a lot of data. And why do we talk about big data now? Because we're adding more sensors everywhere. We want to record security cameras. We want to see vehicles. We want to see people, face detection. And we're adding more cameras, more monitoring. Big Brother wants to watch us more and more. So we have all this data, so we need to process it, and then we have to handle large amounts of it. So sometimes we're talking about quantities which really would take years to process. But using accelerator cards and other technologies, we can actually do that in a short amount of time. So we can analyze that data. What generates big data, these are where are the big players, the fintechs, banks. They manage billions of transactions a day. They have to look at fraud. They have to detect fraud. They have algorithms for that. So just say we're in this country today that we have billions of transactions taking place. During the day, all of this information is gathered here and it's processed at nighttime, or it could be processed real time in other countries who are in their night phase, so that it's using the network at its lowest traffic period. So, and they process all of this big data and they want to do it as quick as possible. So security cameras, banks, governments, they generate lots of big data, but even just the commercial user, the everyday user is already using more sensors, connecting more devices. And there's a lot of data and metadata associated with the connection of those devices. So yes, so big data it can be complicated, it can be unstructured. The key point is that in the future, just as and now, each year we're seeing more and more sensors, more and more data sources being generated. So every time we're recording something and trying to process something, trying to monitor something, we're generating data. Apart from the normal internet searches, social media, streaming, maybe streaming Netflix, smartphones and tablets. I mean, just associated with, if we're walking down the street, our phones are pinging 200, 2,000 different modems. So actually, every time it pings it, it's saying, I'm here, and it says, you don't have access to this network. So even all of that data is useful for governments and carriers to, they can actually track your movements with that. So that's a lot of metadata you have there. And that's a gold mine for agencies and for people that are worried about security. Devices now have multiple sensors. Even if they don't use them that much, they'll have them in their accelerometers, maybe Wi-Fi modules, temperature sensors, all kinds of different modules that we have in there. Same with industrial machinery, to detect when it needs maintenance. Things are wearing out. And all vehicles are getting much more intelligent, from the cabin driver monitoring to see if the driver's sleepy, to the environment, if it's a good temperature inside there. And obviously with the new electric and hybrid electric vehicles, we have lots of types of monitoring going on with those vehicles. So that was talking about data, where our data sources are, and what trend we're seeing, how this can increase in the future. Now we're going to talk a bit about AI, automation, and machine learning. So automation, you can consider it to be part of artificial intelligence or a subset. So basically, AI, we're trying to make machines sort of mimic and maybe supersede human behavior. So we want something to, maybe for simple routines or complex routines, we want to replace the human operator that could get tired or make a mistake with something that will make less mistakes or be perfect. Okay, and apart from that, it will be cheaper as well in terms of manual labor. Automation is something which has sort of evolved into production. So we've replaced workforces with automated processes. So we can have robotic arms moving something from one place to another, mounting parts onto a PCB. These are robots already pre-programmed, and they're doing this instead of people, and they make less mistakes. And they can also be programmed to detect errors and make corrections. Okay, so it's mechanical labor instead of human labor. We're seeing it more in the production lines and in factories. And these are being incorporated with computers and cameras and lots of other things. So what happens when you start to create automation with AI? Well, we want to make this thing maybe smarter, make more decisions. So what you do, you train it with data. You always you have an engine there. You have to train it with some kind of training data. What's correct, what's not correct. You'll do it, train it with neural network. You'll and there's lots of third-party tools for this. And you'll have an access to, these days you'll have an access to libraries which are already made for certain for certain applications. So these libraries will help you develop your system, develop your code, and see if it behaves as you wish it to behave. And then you have to test it to see if what the error rates are. I put two graphics here because people, there's a debate going on if how artificial intelligence, machine learning, and deep learning are related, if they're subsets of each other, or if they overlap with each other. And yeah, there's lots of information on this if you want to look at that afterwards. So if you want to develop algorithms for machine learning, we want to do this to automatically improve using the data received or generated. So the more data we have, the more we can improve it. So the training builds up a model. On the graphic on the left-hand side, we see a backpropagation algorithm. It's the basis of learning about neural networks and making decisions and predictions. So we have a similar thing going on with these third-party tools. We use these types of decision-making algorithms to help us make these decisions for these applications. So yeah, the advantages we know: they're faster, more efficient than humans. They can have large data sets. They don't get tired, and it's sometimes it's easier to teach the machine to do it if it's maybe straightforward, and than to do the task. So third-party tools, there are a number out there. There's more that I'm going to show here. The OpenVINO toolkit. So if you get a platform, if you get some hardware and you want to develop an algorithm, there are tutorials, you have data sets, and you can actually, there are examples as well. You can actually go through the process and learn how to do an object detection with real data and develop something with your reference images. And you go through the classifications, randomization, grayscaling, everything that you need to do to be able to make a good decision-making process. So these are the links here, which I've got here. It can be this for thinking about machine vision and audio. There are lots of function libraries available and algorithms that you can use. Similarly, the other known ones are TensorFlow and Caffe. Same thing. You have libraries on hand. Think about vision, audio, and voice. There are libraries available. You can follow tutorials, and you can start to make applications that emulate human behavior. So you don't actually need to buy a specific piece of hardware to do this. They have like say, industrial computer version. They have a mini version as well. But you can start developing the application before you've actually developed any hardware. You can do it in parallel. Okay. So augmented reality, what do we want to do with augmented reality? We want to overlay visual, auditory, or other sensory information onto the world as we see it, maybe with a pair of glasses, maybe through our tablet. We want to maybe see something, in maybe doing a development or monitoring a process, and we need something to be telling us something is wrong. Maybe we don't see it physically, or highlighting areas where it's detected a fault. So we can this actually exists today. So maybe with a tablet, you'll pass over the device and it will point out an error on that part. So, and that could be in a production line. But obviously, there's the other ones, the more interesting features maybe for the community would be gaming, simulation products, promotion in the advertising industry. Maybe you'd see the product, but you'll maybe see like a holographic detail there promoting something else, or something that which calls the attention to the product. So the augmented reality applications could be in the commercial sector, could be much more desired. Assisted workplaces in factories. Okay, it could be visualizations in a development studio for design or something. So now in this section, we're going to talk about maybe some of the technologies we can see with Synaptics. So yes, so basically, as you'll see on the Synapse website, there's a lot of focus on IoT, AI, and human-machine interface. So things you hear, you touch, you see, how you're connecting and perceiving, how things are perceived by the technology. So we want to think of all these advanced multimedia capabilities, right? Voice, face recognition, video processing, the next generation of products that are coming out there. How is it going to be better than what we have now? Okay. So we're going to see this specifically for signage and monitors and conferencing. But yeah, in the next section, we'll touch a bit on what we have with Synaptics. So we'll talk about video, vision, and audio here, and some of the trends. So video processing. So we expect to see, what do we expect to see now when we see a TV or something? We'll see 4K, HD, clear, crisp images, rich colors, good contrast, no ghosting. We don't want to see ghosting, no ghosting. We want HDMI interface. We don't want to use that VGA connection anymore. We want Wi-Fi connectivity, maybe satellite, cable, terrestrial, internet connectivity, all those types of things. That's what we expect to see. And then what do we expect on the advanced features? With your TV, it's just you can think of it like a big computer. So just as our laptops have cameras on them and our phones, we can have cameras on our TVs, or we can add cameras on there. So if they're already integrated, we can turn our TV into a video conferencing device, okay, and subscribe to a service. That already existed, and then it was a bit more regulated, and then I think it's coming back in a bigger way now, especially during this pandemic. Augmented reality, maybe we've seen something we like, and we want to maybe imagine how it looks on us, so that the camera could actually scan us and give us a preview of what it could look like. Maybe right now, especially during this pandemic season, we've done online trainings, maybe do online sports or something like that, and you can have an instructor on the other side. Or is it something an AI assisted assistant could help you with? You know, it's like you're doing something wrong, where you see yourself in the error where you need to straighten your back, you need to sit properly, you need to do your pose properly. I guess more attractive than that would be the interactive gaming, playing with your friends. So becoming part of a console where you're playing with lots of other people. So co-gaming or co-watching programs together and being able to interact with your friends. So that's what we're seeing. We're seeing smart monitors where we have a home office shared by the household, wireless docking, where we want to, we take a device into a place, we dock it, and we want to be able to automatically connect to that network and not have to plug things physically into the device, like an Ethernet cable. So the monitor could, as we know, has the camera and can be used for video conferencing. It can be used as a digital whiteboard as well. If it's a touch screen, we could use a digital whiteboard. We could share that across the network if that's needed. Biometrics, so that we automatically log into, instead of typing in a password, we just touch a sensor somewhere, or it looks at our faces and we're automatically logged into the household network or the work network. Okay, so that the same thing could be for video conferencing. We're seeing convergence. We used conferencing at work, and now we're using it at home as well, due to recent events. Also, maybe you want to do shopping, online shopping, see things, and buy things immediately. Have that configured so we can just look at online store and order what we see. Again, biometrics fits into this. Smart framing, looking at the outlines of people and adding in a background, and so reducing the bandwidth, so we're not using up all the bandwidth of the whole image that's being captured by the camera. And more importantly, automatic subtitling and transcript. So when you're talking, everything's being written down automatically. For signage, we can look at transportation, where it gives us more information. And we're going to get kiosks at school, student-teacher interactions, enhancement with AI, where it helps you, if you're talking about something, it gives you complementary information at the same time. And point of sales, point of sale systems, which you're finding everywhere. Again, this is taking more data, what's being ordered, where it's being ordered, and at what times of day. So we want to be able to analyze, what people are looking for in ordering. So what can we do here with Synaptics, right? So in this section, we'll maybe just look at our chipsets, what they can do. So advanced multimedia capabilities. So we have a number of system on chip, different versions, higher end and lower end. So for conferencing, I mean, thinking of multiple camera streams, we want to reduce latency so we don't get things out of sync, so we can have a real conversation. It sort of exists now, but we can always improve. And we have a technology which is point to point, which can reduce this latency. So we have improvements there. We want to be able to maybe already have the ability to put it in mosaic form with our chipset. That exists. We want to encode that camera input and maybe a whiteboard as well, or a Zoom version of the camera input that's there, and we're able to dock automatically. So just remembering, this is all one system on chip. So a lot of these features are on the same device. They're not multiple devices. So a lot of these things can already exist, but maybe not all in the same device. Okay, so we can have multiple encodes and decodes simultaneously. So what other things? So next generation of devices that we develop, face or voice recognition. We said voice recognition, maybe we don't want like a whole conversation, a whole book. We're talking about a phrase or simple commands. So this device has a neural network processor on integrated there. So basically you have trillions of commands and the trillions of bytes of data. And basically what we can do, we can have a trained phrase recognition on there. So that device is almost pre-configured to be able to do things. So then when you get your device, you can train to recognize that phrase with your voice. But this device also has the ability to develop or add in those features where you display subtitles and create transcripts as well. So this is maybe a very futuristic application. I mean, it's something that could be coming up in the next 2-3 years in a bigger way than we're seeing right now. But this already exists. And in the terms of processing, framing, we're always framing stuff now, adding in virtual background, detecting who's talking, how many people are in the frame to be encoded and being transmitted on these streams. So that's included in here as well. Panning, autofocus, virtual backgrounds. I've seen some recently where they move. They're not static. Virtual backgrounds actually have movement in there, so it feels more natural. So there's always things that can be improved in terms of processing, and also scaling for different screens and monitors, and so that they improve in terms of contrast and colors. Okay, so we're always looking to improve that quality. So we have these types of features in the multimedia SoC. So here, thinking a bit about the industry where it's going. So we're seeing video conferencing, gaming, watching TV, and maybe security at home, right? So we can see on this table for video conferencing, you've got automatic logging in, object detection, maybe for determining the backgrounds, also scaling for video, and also creating transcripts and auto translation, something that can be developed and added in. Gaming, we want to identify the gamers, detect faces, maybe to see our friends, or maybe gaming movements if it's sort of Nintendo Wii type thing where you're playing. Watching TV, more and more for sports and for programs, you want to know who the actor is, who's playing, who's scoring goals, what the stats are. All of that could be things that are sort of added in, sort of advertisements. What is some actor wearing, a nice suit that they're wearing? Maybe you want to know what kind of suit that is. So all that extra information can be embedded there as well, and can be also activated with a voice assistant. Home security, when detecting intruders, gunshot detections, breaking windows, maybe night vision for security cameras. All of this can also be integrated. So just a couple of smart applications. So here, smart monitor system, workplace using a whiteboard, having business video calls, being able to dock and share the desktop. Also, potentially playing, streaming movies, at home, talking to friends and family, co-watching. So these days, this could go into, a monitor, a set-top box. But what are people asking for these days? Android SDKs and basically voice commands. So if you see this chipset, we can see we can have multiple camera inputs, microphones, speakers, USB, HDMI output. All of this can be done with one system on chip, and it has a neural network engine on there as well. Similarly, for the smart signage, point of sales at quick service restaurants, we want to know what people are buying, who's returning, what their ordering habits are. Tourism kiosks, we have tourism kiosks to help people get to their destinations, get more information, translation, bus stops, real-time information, integrate with digital adverts where we can charge for co-advertising with other companies. And skill kiosks, looking where we can help students with more information, where they can access more information. Instead of going to the library, maybe they can access it from the kiosk itself. And we even have a tutor call where they can call their tutor at certain times and get more information. Again, what kind of interfaces are people asking for? Android, where we can make our development and configure our interfaces. So again, these devices, these multimedia socks are good applications. And just quickly, we'll talk about these key elements. So we have audio ICs, video interface ICs, display drivers. So we can deliver rich sound, clear voice comms with high quality mics. We want to be able to dock the equipment when we can. Maybe think of head-mounted displays, maybe virtual reality. We want to look at multi-stream transport for DisplayPort and HDMI for those interfaces. And display driver interfaces to support this LCD and OLED panels that we're seeing today. So yes, just a summary. We have audio socks with DSPs, and we can detect far-field voice, multimedia socks, system on chips to create that immersive home entertainment experience. And obviously security, not to forget that we have advances in security so that hacking can be avoided. And we have the framework for that security as well, which can be developed further inside the devices. And now we'll pass over to my colleague, Raul, who will talk about wireless solutions. Thank you.
Hi. Also, we can offer you the wireless solutions. Now we are seeing that Wi-Fi 6 is coming into play. What is Wi-Fi 6? You may have seen it as Wi-Fi AX. If you remember how it's been BGN, AC, now Wi-Fi 6 is AX. And what is driving this change? As you can see, here we can see the velocity that we can achieve with Wi-Fi AC, Wi-Fi 5, and Wi-Fi AX, that is 6. It's higher speed. Also, it helps the systems to provide more nodes. So what we achieve with this is better connectivity, because most of the devices right now that we're seeing in the IoT needs connection to the internet, and this is to make it in the Internet of the Things, because we want to use the cloud systems, we want to have better functionality, do better automations, etc. So that's why we are seeing this trend. Also, we will see that there is a Wi-Fi 6E. The E is for extended. The extended is on the band. So Wi-Fi 6 can go, well, 6E can go from 5.9 to 7 gigahertz. So it's more bandwidth, 1.2 megahertz of additional spectrum that help to have more devices connecting more quickly. although we will see some duration of the signal, because at higher frequencies, the wave travels less distance. We will see that more and more devices now are near the spots, the hotspots. So that we can help with this. Next, please. With Synaptics, we have 3 types of technology. As you can see in red, green, and blue, it says which are the lengths of technology used in nanometers. The last is 16, no 162, it's like 16. It's even shorter. Less space taken, better performance we obtain. And here are some examples that we can offer with Wi-Fi 6. We have 2x2, Wi-Fi 6, and Bluetooth that are compatible with PCI Express. Or if you need lower, we can have a 1x1 also, Wi-Fi 5 or Wi-Fi 6. And it's coming the Wi-Fi 6E in the 16 nanometers. You can see there that we have 1x1 and 2x2 in Wi-Fi 6 extended. And those has also the combo of Bluetooth 5.2. Next, please. Next. So along with those, sometimes some of the devices will need some audio SoCs, DSPs, amplifiers. With that, with Synaptics, we can offer a Class D amplifier. We have the control, the digital control, and the audio outputs. Also, sometimes you need to have more power. We have smart DSPs features. DSP is a digital signal processor. Sometimes you need to modify, apply some codecs to the audio wave in order to process it. So, for example, these Synaptics that we are showing here, it has for microphone, for field voice, so it can support better the way to be using the noise cancelling, and also to have better input of the voice. We have the voice trigger, so if you start talking, it can wake up the device. Also with this, we can see this 360 degrees smart source locator. This is in order to start seeing where the voice is coming from. So with more microphones you have and the power processing that we have with this DSP, we can achieve that. Also in the SoCs, you can see 24-bit and 32-bit digital audio. So these are very powerful devices that can help you in all the audio features. Next, please. Also, we have to offer some biometrics and touchpads, touch buttons. Next, please. For biometrics, we can see that we have this fingerprint sensing. This is intended more for laptops, as it requires operative systems. It's not standalone. It requires a software to be able to read and compare the fingerprint. But if you are doing a bigger device, when you are using a microcomputer in there, you can have this fingerprint sensing that is very, very secure. Also, with Synaptics, we have touchpads. We have 5-finger tracking. These touchpads are seen in several laptops, several brand names that you can find within the US, as it's very robust. It's been several times since Synaptics is doing this. Next, please. And also we have the sensor solutions. This is with Asetek. This is a brand with smaller ICs. Next, please, that can help you. As we're seeing here, we have a combination of sensors, very small ICs, and depending on the project is what you will need. Those are very, well, ultra low power solutions. You can find them in several devices right now. Next, please. For example, you can see in their earbuds, there you need some touch and detection capability. So, for example, here we see the 4-in-1 for TWS. Touch, swipe, force, wear, detect. So it will detect that the device is in use in the here, for example. The button, as you see, is only the plastic, the inside is sealed. What you do is you deflect a foil of metal, and the IC has this inductive sensor that can detect this deflection, so it can be read as a push button. You can design things that are waterproof and tamper-proof. For example, in tamper-proof, this same functionality that is bending the foil, what you do is when you are going to seal the system, you place a foil. And if you detect that something is messing with it, because the sensor will sense it, you can react, either erase memory or send an alert, etc. Next, please. Here we can see some of the applications we find right now. In hearables, a lot of wearables, gaming, extended reality, speakers are using it, those a lot. The home automation we are seeing, because you can have touch buttons, swipes, pads, several things. You can see in toys, in peripherals. So this is a technology that will help you and to do better and better devices. Next, please. Here we can see another example. Here is an alarm control. So you can wake up the fingerprint reader because you will sense that there is a proximity in there. Also, you will have touch keys. You can implement the tamper-proof. You can implement proximity backlighting. You can have, for example, this can track up to 5 fingers at the same time, so it's very powerful. Next, please. And now we're going to talk about memory.
So we already know that the more data we need to process, the more memory we will need within our system. Sometimes the processors or some microcontrollers, let's say, already has some kind of memory, but whenever we need some more memory, we can offer you, we can work with some other partners that can help you on these solutions. Micron is a solution that can help us with memories, whether we need a volatile or non-volatile memory, a product for that. We can memories that as the one that we can see. For example, DRAMs, we have or flash NAND or norm flash. Yeah, we have the discrete solution, or in case we need some maybe end products, let's say we have memory card or solid state disk. Also, processors, we know that they require different rate voltages. So with MaxLinear, we can do some. We can help with some part numbers that can help with the different a PMIC that can help different, maybe up to 4 book solutions with different rate voltage or an LDO. This will be, or this can be pre-programmed to offer the different voltage at different timing. depending on of the processor needs. And finally, some connector needs. We have the support from Amphenol ICC that can help you with a lot of connectors. We have a big portfolio of connectors, but specifically for high-speed solutions, we have a couple of families, some families that can help you on providing the correct solution. With the Flex family, with the Flex solutions, we can have solutions that with data rate up to 10 gigabits per second. And they are compliant with USB, PCI Express, SATA, DisplayPort, and even MIPI for wherever the needs are.